Thank you. Hi, everyone. So, can I ask you, just to judge, what's the level of the audience? How many ML engineers or data engineers are in the room? Right, okay. So, just saying that because part of the presentation will lay the basics for the rest of the presentation. So, okay, so my name is Manuel Herranz. I've been CEO at Pangeanic for the last 20 years. The company is the result of a friendly buyout of a larger Japanese conglomerate. And since 2007, we've been working on pattern recognition, which is one of the basics of machine learning. If I can, okay, right. So NLP, the area that Pangeanic specializes in, is part of the grand science called artificial intelligence, and it focuses only on language processing. That can be text, it can be voice, it can be image, can be multimodal in many ways, but it allows you to extract, to classify, and to process language so you obtain information on a scalable way. And everything started, I like always to mention this guy because he's my hero from my student days in Manchester. Alan Turing is the father of artificial intelligence, and he laid out what is known by everybody, the Alan Turing test, basically stating that when we have a machine that can fool a human at a conversation, the test was having one person trying to discern a chat to another person in a room or a machine. If we could tell apart what the machine was or the human, then we would have achieved a high degree of artificial intelligence or machines that were as good as humans, at least at a task, not in a general artificial intelligence, not general AI, but in one task. So that task could well be playing chess, could be translating language, could be classifying language, could be understanding what a text has, so we can tell other humans. And this is the beginning of everything. This is one of the reasons why we are here today, and there is an industry on NLP and artificial intelligence. So much so that the amount, I don't want to mention how much data is processed every day. I'm just going to focus on the amount of personal data that is processed or is generated every day. It's 2.5 quintillion bytes, which says a lot about how many transactions or how many traces, and that is important, the key word, how many traces of our personality, of what we do, we live on the cloud, on the internet, or platforms. And I'm not sure that you can read the interesting bit at the bottom, but the quote says that personal data is considered to be the oil of the 21st century, and I don't know any country in the world that would not like to have oil nowadays. Which raises the question of ethical AI, of an ethical use of personal data for a variety of reasons. Very good reasons can be healthcare. So if I suffer a kidney disease, for example, and any research done on me can be shared, so other patients don't suffer what I have, and doctors or healthcare companies can provide better solutions. That's a very ethical and very good use of my data, but perhaps I don't want to be named. I don't want to be recognized as the person suffering that type of disease. That has led to many issues and many challenges in the process of personal data. There is legislation, both sides of the Atlantic, more strict in the EU, where we come from. There are many things that you cannot do in Europe with personal data. You can't sell it, you can't reutilize it unless there's a very good reason. You can't monetize it, of course. But out of that 2.5 quintillion bytes that are generated every day, not everything is English. And looking at you, there are speakers of many languages here, leaving traces of their personal data in many, many languages. That's challenge number one. We are producing multilingual data that needs to be processed and understood in my language, whatever my language happens to be. The data that we produce is multimodal. It can be video, can be an email, can be our interaction with the public administration. It can be voice. Another issue is compliance by law. There are regulations more strict in some jurisdictions than others that allow us to process that data in a way or not in a way. There are certain things that you can do to provide data in countries such as Australia that simply would not be legal in Europe or Japan. And then when you process personal data or content, big data having some type of personal data, you need to do it at scale. That is always an issue. So we're going to see strategies to overcome these hurdles and always stay on the good side of the law and stay compliant. So challenge number one, being multilingual. Well, around 6,000 to 7,000 languages in the world. Everybody produces data, from Telugu in India to Mongolian to English or Spanish. And every type of data in a language is valuable, be it for market reasons, be it for scientific reasons, for healthcare, for insurance, for banking. Data is multimodal. It can come in the shape of video. We have a video anonymization demo outside. It can be speech. It can be text, mostly. The compliance issue, as I mentioned, we're going to stay on the good side of the law, not the bad side of the law when we run our ML operations. And very interestingly, when we scale, we may be able to monetize it. We may be able to make some money on the data that we have. Let me give you an example. To come to this conference, had to board a plane, go to Paris, change planes in Paris, and then I'm staying in a hotel in New York. Now that trip can be very beneficial. The data on that trip can be very beneficial for the organization handling bookings. But the fact that the booking knows, or that data is spec to my name, so they know what plane I boarded, they know the hotel I'm staying, perhaps it's not so good. And I understand that that organization needs that data in order to provide a better service and even send me offers on more trips to New York or more trips to North America. But whether they monetize that data with my name, it's not so ethical. So let's start with a good side of NLP and how NLP works. Classifiers. Classifiers work on many thousands and millions of tags, and those tags initially, some years ago, and even now, tend to be manually tagged. So I tag a document to be a contract, I tag a document to be a negative email, a positive email, a conversation, good feedback from a call center, for example. And I feed all this type of data to a neural network with the hope that the neural network then will help me classify my data lake or my incoming data dynamically. Systems are becoming so sophisticated that we are approaching the level of humanness or human quality classification levels, even with subfields. So we know that a document is legal, that a document is healthcare, that a document is legal and also penal. There are some issues at court with it. The document is related to human resources, etc. Classifiers are not rocket science. Okay? They have depended a lot on human labor, less so nowadays. A lot of them are trained on artificial, on synthetic data. This is the way of Kanagawa. People talk about data lakes on their organizations. I rather speak about data waves or seas of data that need to be organized. Because they need to be organized in a dynamic way. Silos will exist and will exist forever in our organizations. But and more data will be created and added to them. What we need is systems that can extract that data dynamically to be processed by central operation system or by our own filters. So that's the little bit about the classifiers. Named entity recognition, this is where the fun starts. Everybody wants to extract data to obtain value from it, to understand what's going on their silos or the big data repositories. And each one has a different case. In this case, the user wants to know more about the way apps are being installed in cell phones and what type of charge is being implemented. Okay? So that type of entity recognition, charges, cell phones, apps, is very different to the type of recognition that we need in another language to understand what people, places, and clauses in a contract. And here what we need to recognize is who signed what, at what date, for what value, and whether the contract is compliant with any legal clauses. This leads us to the area of identifying actors, identifying people, and people's information in documentation. So we have fun with text that contains personal data, and we identify the actors and the entities in that data. In this case, we have a biography that is not harmful to anybody, it's Superman's biography. But you can see that this type of text can also apply to curricula, CVs, personal data, personal records. And it's the same technique. It's the named entity recognition specialized on personal data. One of the challenges is that this has to work in any other language. Has to work in Japanese, has to work in French, has to work in any language for which we need to mask and be ethical about when creating synthetic AI data. Gartner has a very interesting report on data masking, a little bit outdated, it's 2021. They speak about data masking industry as something that is mature, and is partly right. Structured data masking is mature, but only if you consume the products of Oracle. Oracle knows how to mask their own data on their own databases. People that use MySQL know how to mask data on MySQL databases. The challenge is to do it on structured content of any shape that can contain images, people's passports, IDs, and can come in any format, from a PDF to scanned image, picture, or a doc, or a Microsoft Word file, or Excel file. So we've seen anonymization so far. Anonymization can be broken down in different techniques. The most popular one is reduction, that we are very familiar with because everybody's seen Panama Papers. So basically you detect the actors on a text and you black them out. You use a black lining. Not reusable, it's completely irreversible, it is shareable. You can share this type of information very efficiently with people in your organization or outside. Second technique, and the one that is more attractive, is obfuscation. We use obfuscation to mean anything that happens on image or video, as you can see outside. In this example, we see a young boy whose face and whose number plates have been obfuscated with very practical uses for law enforcement on streets, when you want to focus, or you need to focus on certain people in a crowd, but you don't want to process the details of everybody else in a crowd. For structured text, we use anonymization, so that is set. All types of emails, names, jobs or titles are deleted, also irreversible. With very different techniques, hashing, averaging, shuffling. Each application requires a different way of solving the issue, but at the end of the day, you end up with data that is processable, usable, but doesn't relate the text to the user. And lastly, we have pseudonymization, in which data or names are substituted by fake names or numbers or tags. And this is the part that companies are interested in to monetize. What you want to do and have really is a strategy that allows you to keep your data safe, so you don't happen to be on the side of, you don't happen to be the victim of a cyber attack and your client data is stolen. I like to mention my electricity company because I was not happy when they were hacked and my personal details with the average of my electricity consumption became part of data release, data leakage because of cyber attack, and they didn't have any way to split the data between users and consumption. Not staying compliant, at least on Europe and Japan, Brazil, and many jurisdictions, can lead you to trouble, can lead you to fines. Again, just to repeat, all these techniques boil down to recognition of entities, recognition of people, recognition of ages, job, family relations, which provide data that is scalable, that needs to be anonymized, masked, in order to be processed legally. So today we've seen very quickly how data classifiers work, how named entity recognition works, what are the types of anonymization and data masking solutions that are out there, and why they're important. Number one, because there are regulations and laws we need to comply with, of course, but also to build trust in our brand by becoming a company that processes data in a responsible and ethical way. And that's it. I think we are staying on time. Yep. Thanks. Questions? Yes, of course. You're open.
So, how does this fit into the right to be forgotten?
Pardon me?
The right to be forgotten. So, is this parallel efforts or is this need to fit into this landscape?
Yeah, parallel efforts. Okay, it's not the same. The right to be forgotten is the right to be erased from somebody's database, but it works in a similar direction. It works in a very, very similar direction. You can call this the right not to be forgotten, but the right not to be named. Thanks.